Okay, so now let's talk about finding solutions of trig equations and just going for it. You guys have learned all the basic steps. We know what we're supposed to do, the 2 pi k for the sine and cosine, and then just pi k for the tangent. So let's look at this. So when I try to solve these, I almost think of the cosine or sine. I almost think of this as like an x value. So if this was an equation like 4x squared minus 3 equals 0, what are you going to do? You're going to first get the x by itself, then square root and solve. So same thing we're going to do here. We need to get this cosine by itself. Once I have that, so let's get this cosine part isolated. So I'm going to add 3 to both sides, and I get 4 cosine squared theta equals 3. Divide both sides by 4, and I get cosine squared theta equals 3/4. Square to get rid of that squared, it's just the same thing if I had an x squared. So if I had x squared equals 3/4, to get rid of that, you would square root. So it's the same thing we'll do here. We're going to square root both sides to undo that square. And remember, whenever we square root, it's plus or minus. So this gives us cosine theta equals the square root of, let's see, plus or minus the square root of 3/2, because the square root of 3 is square root of 3, the square root of 4 is 2. So we get cosine of theta equals plus or minus root 3/2. Beautiful thing about this is we have that restricted domain. So let's think about, where does cosine theta equal root 3/2? If you think about your lovely chart that hopefully you've written by this point, you could also look at your unit circle. Cosine is going to equal root 3/2 right here. I don't know where in the world that came from, at pi/6. So we've got pi/6. Pi minus pi/6 is where it's going to equal negative root 3/2, which gives us 5 pi/6. Pi plus pi/6, which is 7 pi/6. And then 2 pi minus pi/6, which puts us at, let's see, 8 pi minus pi over 8 pi over, I cannot think right now. Let's do this. See, even me, I have to sometimes do this without doing, I cannot do these in my head. Okay, so this would be 12 pi over 6 minus pi/6. So that's 11 pi/6. Brain fart. All right, so there's your values. And luckily we can stop right there because they restricted the domain. If they didn't, you would take all of these values and you'd have them, and you'd have the plus 2 pi k. All right, solve this next one. So this one's a little different because we have this 2 theta here. So that's going to affect our period. Remember that when you have that b value in front of your angle, that affects the period. So we're going to see kind of what that does here. All right, here we go. Deep breaths. So first I'm going to add 1 to both sides. Cool. Again, I still need to isolate that cosine. So divide everything by 2. All right, so now at this point, I have it. So I need to figure out, where does the cosine equal 1/2? So cosine is going to equal 1/2. Again, if you're thinking of that unit circle, that's going to happen at pi/3. And then that's going to happen again at, let's see, 5 pi/3. So 2 pi minus pi/3. So pi/3. And then again, cosine is positive in this quadrant because cosine deals with the x. So using that as my reference angle, that would be 2 pi minus pi/3, which gives me 5 pi/3. So we know what's inside of here has to equal pi/3 or any revolution of that, or whatever's inside there has to equal 5 pi/3 or any revolution of that. Okay, so again, the way you're thinking about it is we're figuring out what angle. I'm not even dealing with that 2 theta yet. What angle, when I take the cosine of it, gives me 1/2. So that's going to happen at pi/3, and then it's going to also happen here with that reference angle of pi/3, which gives me that 5 pi/3. Okay, so I found my 2 angles, and then I have to add the revolutions because I don't have a restricted domain. So what's inside the cosine isn't just theta this time, it's 2 theta. So whatever theta is, I have to double it, and when I double it, I need to get these answers. So to solve for theta, right now theta is getting multiplied by 2. What's the opposite of multiplying by 2? Dividing by 2. So in this case, we get theta equals, we get pi over 3 divided by 2, which is the same thing as multiplying by 1/2, and then 2 pi over k divided by 2, because you have to divide that 2 to everything. So that gives us pi over 6 plus pi k. When I do it over here, same deal. Divide everything by 2. So theta equals, when I divide that by 2, I end up getting 5 pi over 6 plus pi k. Okay? So at this point, you're probably wanting to stop and say, cool, I've got my 2 answers. I solved for theta. But what you could realize too is that all of the revolutions of this are going to also give us these revolutions. Because if I take pi over 6 and add pi to it, guess what I get? 5 pi over 6. So technically, once I solve that, there ends up being only one answer to write for the general form, because that takes care of all of these answers as well. Okay, so let's do a bunch more practice problems. Now, letter C is great because the cosine's already isolated by itself. Lots of people, including myself, sometimes freak out when they don't just see theta, but they see 4 theta. My advice, don't worry about it. Let's first think about when you take the cosine, what angle when you take the cosine of it gives us -1/2. Well, that's going to happen. Cosine deals with the x values, so that's going to happen here and here. The reference angle that gives us 1/2 is pi over 3. So it'll be pi minus pi over 3, which puts me at 2 pi over 3, plus that 2 pi k. And then again at pi plus pi over 3, which puts me at pi plus pi over 3 is going to be 4 pi over 3, plus 2 pi k. Oops, let's leave a little more space here. Sorry if you already wrote that. Okay, now, this, what we're taking the cosine of, is 4 theta. So that's what 4 theta has to equal. It needs, when I take my angle and multiply it by 4, I need to get 2 pi over 3 plus a revolution of it, or 4 pi over 3 plus some revolution of it. So solving this, what do we need to do to get the theta by itself? Right now it's getting multiplied by 4. Opposite of that is dividing by 4. Okay, so we are left with theta equals 2 pi over 3. Dividing by 4 is the same thing as multiplying by 1/4, plus 2 pi k divided by 4. You have to take that 4 and divide it to each term. So that gives us 2 pi over 12 plus pi k over 2, which is pi over 6 plus pi k over 2. Okay, same kind of deal over here. Take this, divide everything by 4. So when I do that, we get theta equals 4 pi over 12 plus pi k over 2. So pi over 3 plus pi k over 2. So these would be the general solutions. So if you're asked to find the general solutions, that's it. There they all are. But this specifically stated to find all the solutions that are between 0 and 2 pi. So let's just start listing them. So to do that, we'll start with letting k equal 0. So when k is 0, this first equation is just going to be pi over 6, because that goes to 0. And the second equation is just pi over 3, because that goes to 0. So I'm going to actually write these answers right up here. So we get pi over 6 and pi over 3. Those are all between 0 and 2 pi. Sweet. So now let's let k equal 1. So when k is 1, for this first equation, I get pi over 6 plus pi times 1 over 2. Get that common denominator. So that common denominator is going to be, let's see, 6. So this needs to be multiplied by 3 over 3. So that gives me pi over 6 plus 3 pi over 6, which gives me 4 pi over 6, which reduces to 2 pi over 3. Totally within this domain. When I let k equal 1 here, I get pi over 3 plus pi times 1 over 2. Common denominator again is going to be 6, so that becomes 2 pi over 6 plus 3 pi over 6, which gives me 5 pi over 6. Okay, now we'll let k equal 2. So when k is 2, in this first one, we get pi over 6 plus pi times 2 over 2, which is just pi over 6 plus pi. So pi over 6 plus pi is 7 pi over 6. When k equals 2 for the second equation, I end up getting pi over 3 plus pi times 2 over 2, which is just pi. Pi over 3 plus pi is 4 pi over 3. So hopefully you guys get the gist. You keep on doing this. When we let k equal 3, you end up getting a few more answers, which gives us 5 pi, over 3, and 11 pi over 6. Okay, and then after that, we end up getting outside of this 2 pi range. So that's how you do this. All right, let's look at this second one, the tangent one. All right, unfortunately for this guy, tangent's not alone. Dun, dun, dun. So we need to get the tangent isolated. First thing, let's subtract that 1. So when I subtract the 1, I get that. Divide by root 3. Simplify that out. Oopsies. Tangent of 3 theta equals negative root 3 over 3. All right, so what angle gives us negative root 3 over 3? So that's going to end up happening at negative pi over 6. So again, what we would do is we would take the tan inverse of both sides. And we get that 3 theta is negative pi over 6 plus that pi k. All right, so now we need to think about this. This 3 is on the outside with the theta, so I need to get rid of it. So to undo that, divide everything by 3. So I get that theta equals negative pi over 18 plus pi over 3k. So now to figure out what theta is, you're going to start with, let's let k equal 0. So when k is 0, we end up getting that theta is negative pi over 18, which is not in the domain. So that automatically gets crossed out. So now let's let k equal 1. So you'll let k equal 1, and you'll continue doing that until you found all the values that spit out that are between 0 and pi. So those end up giving us 5 pi over 18. (11 pi over 18 when k is 2. Why is that not coming up? And when k is 3, we get 17 pi over 18. And then at that point, we cannot go any further, or we are out of bounds for the domain. All right, let's look at 2 more examples. So this one here, the first letter E, that comes straight from what you would have done in math 65 and 95. So if we were solving this, this is a quadratic, we would take it, we would factor it, set it equal to 0. So when I factor this, let's see, we're going to get -1 plus 1. So then you set each of those factors equal to 0. and solve for x. So you got x equals -1/2 and x equals 1. So it's the same kind of deal that we're going to do here when you have multiple signs in an equation. You can just look at it and you can see how this literally matches up with this. Okay, so it's the same thing. So just look at it by letting sine equal x squared. If sine equaled x. So if sine equaled x, we would have this exact equation. Okay, so I can factor this. So this would factor into 2 sine of x, Okay, so again, 2 sine times sine is 2 sine squared. All right, so now we need to get it. We've got the -1 and +1, so when I FOIL this out, I get plus sine minus 2 sine, which leaves me with negative sine of x. So again, when you're looking at these questions, like if you're given one that just looks like this, what I always tell students to do is to convert it to just having x's instead of sines or cosines, factor that out yourself, and then replace the x's with the sine or cosine value, whatever was in your original equation. So that way, when you're doing the factoring, it's not so scary to look at with having all of these different variables. Okay, so now what we're going to do is we'll set each of these factors equal to 0, just like we did here, and solve for x. So subtract 1 from both sides, divide by 2. Okay, so in this case, we end up getting 1 to sine equal -1/2. Okay, well, sine's the y value, so sine's going to be negative here and here. So looking at your little cheat sheet, what gives you sine is 1/2 with the reference angle of pi/6. So that's going to be at 7 pi/6 because it's pi plus pi/6. Again, plus that 2 pi k. And then it's also going to happen at 2 pi minus pi/6, which gives us 11 pi/6. Again, plus that 2 pi k, because we have to generalize it for all of the angles that would land there. And then when I solve this, I get sine of x equals 1. Well, again, sine deals with the y value. It's going to equal 1 right here, which is at pi/2. And then all the revolutions of pi/2. So there's your 3 answers. And again, we're going to say where k is an element of the integers. So when you see these types of equations, they look really scary, but I promise you they're not. Just take it into a problem that you already do know how to do from previous math classes, and then you can kind of translate it over. Okay, so let's do a little more complicated ones. These are the last 2 we're going to do by hand. So when you look at these, they're a lot more sketchy than the ones we did before, but they're really not that bad if you take a deep breath and you remember some cool tricks and you just kind of try stuff. So here's what I'm going to do. I'm going to look at letter G and say, well, this is a bummer. There's sines and cosines and sine squareds and oh my goodness. So I'm going to see if there's a way I can get this all in terms of sine. So I do know something. I know that sine squared plus cosine squared equals 1. So if I solve that for cosine squared, I get that cosine squared equals 1 minus sine squared. Sweet. So I'm going to replace this with this. So I have only sines. So I get sine squared theta plus sine theta equals 1 minus sine squared theta. Okay, still pretty yuck. So let's get all of this on the same side. I'm going to subtract the 1 and add the sine squared theta to get everything on to one side. So I get 2 sine squared theta plus sine theta minus 1 equals 0. Sweet. Now I have it where it's kind of in that form of 2x squared plus x minus 1 equals 0. So I can factor that. If I go and do it this way, you'd see we get 2x, x. This would have to be plus 1 and minus 1 for that to FOIL out into that. So this means this is going to FOIL and factor into 2 sine theta minus 1. Sine theta plus 1 equals 0. So now it's setting each of those equal to 0. Here you'll get sine theta equals 1/2. So sine's going to equal 1/2. Sine is positive here and here since it deals with the y values. So looking at your handy dandy cheat sheet, we've got that reference angle is going to be pi over 6. And then pi minus pi over 6, which is 5 pi over 6. And then I always do that plus 2 pi k. Even though they did show me what their domain is restricted to, I always like to do that just to make sure I don't miss a number or a value. So then when I do this guy, let's do this in a different color. So when I solve this one in blue, we get sine of theta plus 1 equals 0. So sine of theta equals -1. Looking over here, sine is going to equal -1 right down here at 2 pi over 3. Oops. What am I thinking? 3 pi over 2. Oh my goodness, my brain is already shot. 3 pi over 2. All right, so when I let k equal 0, that's pi over 6. When k is 0, that's 5 pi over 6. And when k is 0, that's 3 pi over 2. When k equals 1, this is pi over 6 plus 2 pi, which is going to take us out of that domain restriction. So all of these will. So at this point, we're done. We have listed all of the values of theta that are within that domain restriction. See, it wasn't that bad. All right, looking at this next one. Uh-oh. I've got cosines and sines, and none of them are squared, so I can't use this beautiful trig identity. Okay, so let's think about things. So the first thing I'm going to deal with is I don't like this negative inside the sine function. So we do know that the sine of negative theta is the same thing. I can pull that negative out in front because the sine is an odd function. So that gives me cosine of theta plus sine of theta equals 0. Reason I did that is I just added the sine theta, or I took that negative, moved it on the outside. Negative, negative becomes a positive. Okay, using that whole concept that we learned earlier, that sine is an odd function. Okay, this is still gross, but I kind of see tangent here. Remember that tangent is sine divided by cosine? So here's what we're going to do. Let's move this sine over, because that's legal. As long as whatever you do to one side of an equation, you do the same to the other, you're good to go. Math police will not come and get you. All right, so we get that. Now, watch this. All right, so dividing by cosine of theta divided by cosine of theta is just 1. And I'm left with, well, what's sine over cosine? Tangent. So then I get the tangent by itself, divide both sides by -1. Sweet. So now this is a much easier problem. So tangent's going to equal -1 at 3 pi over 4. And at pi plus 3 pi over 4, which gives us 7 pi over 4. And that's what we get for within that domain.